After waiting 5 minutes, then we'll start our session. So I request you to please kindly wait for some time because I'm facing some technical issues. So I'm just resolving it, and I will start the session as soon it get resolved. Sorry for inconvenience today. So can can somebody confirm that my screen is visible to you?
Yes, sir.
Hello.
Yes, sir.
Okay, and my voice is also clear, right?
Sir, there is a echo.
Echo, sir. Echo, sir.
Hello. Now echo problem is not there, I think. Hello.
Hello, sir. Clear, sir.
Clear, right? Okay. Okay, so I'm just sorry, like I'm using some different system, so that's why this technical problems are there. Sometime it was echo, and sometime the video is not showing. Ah, so Now it is fine, right? My voice is clear. I'm not putting my video on because maybe some bandwidth issue is there, and I will be uh, going to take this session in this mode only. So so today yeah, so I'm sorry, just I forgot to welcome you all. I welcome you all again in the today's session. So we are here in the live eighth live session for this course, product design and manufacturing. I'm Sarit Anand Singh. I'm a prime minister's research fellow in the department of mechanical engineering, uh, IIT Jodhpur. I got this opportunity through PMRF NPTEL TA scheme to take this live session for the NPTEL course having code NOC 23ME14. So this is a product design and manufacturing course, and we are in the eighth session of this course, and today I am going to cover uh, course content of week 9. So in this session, I am going to cover course content of week 9. Again, this session will be in a similar mode. Like to initially, I will be asking you some questions, and you will be answering those questions. The questions are quite similar with the questions that are in the assignment problem, and then same similar kind of question you can expect in the examination also, like not same question, but yeah, similar kind of questions from the like pertaining to the concepts. And then I will take some questions from the discussion forum, and then at last the session will be open for you all. If you have any query related to this course, you can feel free to ask your queries. So before starting this session, this week again is a very interesting, what you can say, interesting week for personally for me also, because uh, I have a lot of experience in the domain of this additive manufacturing and rapid prototyping, and there's a very good, what you can say, a very good piece of information and knowledge that we have get from the course content of week 9. So in this week we have studied about what is all rapid prototyping is, and uh, what is what you can say, what is 3D printing and how 3D printing has evolved, and types of 3D printing and additive manufacturing techniques, and how they are helpful for product designing and manufacturing, right? So if there is any specific query at this stage to you after studying the, if you have gone through the course content, so if you have any specific query, you can ask it to me at this initial level. Um, I just wanted to get like, if you have any query, I will be happy to cover those queries in between the session also, so that it will be very fruitful for you. And like, yeah, if you have any query, please ask it to me. Like that query related to the this week, particularly this week course content, and converging to the additive manufacturing and rapid prototyping. If you have any doubt or anything that you want to specifically know, please let me know, so that I can cover it during this session only. Is there any query, or should I begin with the regular routine, like what we do? Like we have only four participants, so I just request you all, the first question is like, have you gone through the course content of this week, the week 9? Have you all gone through the course content, or to an extent? Yes. Okay. What about others? Muskan. No issue, no issue. Like we are here only for discussion, right? So I just wanted to know, like, like up to what extent you have studied, and what I have like, how should I explain so that it will become
Sir,
more.
okay, okay. Sir, I had a few questions.
Hmm.
Can I ask them related to this course?
Uh-huh.
Rapid, sir, are you talking about rapid prototyping?
Yes, yes, I just
Oh,
wanted to know about like what is your
yes, yes,
like
yes.
up to what label, or up to what extent I said that you guys have knowledge of this additive manufacturing and rapid
Yes, yes,
prototyping.
yes.
Have you studied it earlier, or it is a
Yes,
very
yes.
new technology for you that we are going to discuss? Because if it is a new technology, then I have to discuss it in a certain manner that you'll just love it, right? Because when I saw this technique first time in my career, like in my life, so I was very astonished after seeing this, because I was into this kind of thing. I like, as a human being, we are doing certain things, but as a technology, using the same thing that we are doing in a routine manner, like it is a very next level thing, right? So from like in our childhood, we used to play lot of we used to do lot of activities in our daily life, and especially about our this childhood. So in childhood only we do lot of things, right? So from like making structures from sand, and like making the frames from the small pieces of wooden, right? So all this we have did, okay. And up to certain extent, like in a more advanced way, if I say, we have also did school projects, okay. So we have made certain things, but those are not technically sound, but yeah, we have used and we have did the things, and those things are utilized in the technology. The same concepts are utilized in the technology to do something more better. So this additive manufacturing is and this rapid prototyping is one of the such kind, or one of the such thing that we all have experienced, right? We all have did. Who has not played in his childhood and with sands and all? Okay, if you are very sophisticated, like, pardon me, and ignore that part. But yeah, at a childhood level, like, you also, if people usually used to play with clay and this kind of stuff, right? So in the modern age also, students this the modern age childs or kids, they also used to play with clay, and then mold the clay to make certain kind of what you can say, structures, okay. So that look similar to something, okay. So we already have experience, and this is what we do in rapid prototyping also, right? So that's why I wanted to know, like, up to what extent you guys have the information about that. So yeah, finished two videos. Muskan says, haven't gone through the videos, but you have slight understanding about rapid prototyping. Okay, right. So okay, yeah, Nikhil, you wanted to ask something, right?
Yes,
Hello.
sir. Actually, while no, I was solving the quiz, there were some questions which came to, I was confused because I
Okay.
have studied rapid prototype means additive manufacturing during my MTech, and I
Mm-hmm.
also went through our notes which you have
Okay.
uploaded in the notes means PDF files which you
Yes,
have
yes,
uploaded there.
yes,
So,
yes.
for example, there were on two, three questions I faced some issues.
Mm-hmm.
They asked, okay, some of these are the materials which can be used in additive manufacturing. So
Right.
polymers, surely it can be used.
Uh,
Correct, me, sir. Polymers is they we use them in VAT polymerization, right?
yes,
Metal, 100%
yes.
in sheet
Like,
we use
the
it.
learning.
The
Uh,
third was ceramic.
okay.
So and fourth was all of these. So
Okay.
in my opinion, so I couldn't find anything in this those slides or anywhere. But in the
Uh-huh.
internet, I searched and I could find that yes, even ceramic is used. Now
Yes,
that
yes,
is in
yes,
fact something which is new coming up, and
yes,
that's
yes.
why I thought all of this is the right
Mm.
answer.
Mm. Mm-hmm.
So, so in short, my question was whether ceramic is used, and I said I thought that it is yes,
Yes,
ceramic is
yes,
used.
definitely. The ceramic and metal, these two are the very new domain or new area for research as well as development of technology in field of rapid prototyping and 3D additive manufacturing, right? So if suppose, like, if we, like, till now certain extent of success or innovation in the innovation of this kind of printers, like which can print metal and ceramics, have been achieved. But yeah, lots of research is underway. Okay, so
Correct.
definitely people want to print each and everything that exists in the world. So even from not only ceramic and metal, people wanted to print this skin, muscles. Okay,
Okay.
so if we can certainly print muscles or skin or something like that, so that will be another extent or another level of what you can say,
Advancement.
innovation, right?
Advancement.
So
Yeah,
yeah,
yeah, yeah.
so
Correct.
like for transplantation we required a heart or something, kidney or something like that. If it is required, so we can, if
Hmm.
we have some certain printers, so we can print it. So
Okay.
recently I went to USA, and in the conference I got another idea. Okay, so there's a blue sky competition, so where people used to present ideas that they ideas those come to their mind and they think that these kind of technology will come in another next 10 years or 20 years. So another technology, another what you can say idea I got was food printing. Okay, so food printing is something like, if you want to if you want to eat a certain proportion of protein and carbs, and like people are very much conscious about their health nowadays. Okay, and they are tracking their protein level, like how much protein or how much calories they are intaking. So if using these parameters, if you can print some tasty food, okay, like it may be a vegan food or non-vegan food or vegetarian or meat or something like that. So if a printer can take input from you, okay, 200 calories, I need a food of 200 calories, having sugar of this amount, having salt of this amount, and this vitamin C and this all, and it can decide it by its own self that what kind of food should be better. Maybe it will be a pizza, or or what you can say, a slice of uh, or bread or something like that, or mixture of something like that. So it will be very much innovative thing, right? What you guys say after listening or hearing about that? Have
Yes,
you
sir.
thought about this kind of technology?
No.
Or if it will come in the market, then certainly it will be very much what you can say, in a
In demand. In
yeah,
demand.
in demand, yeah, right. So this kind of innovations and people are just thinking about. So when I was in masters, so at that time we got what you can say, a demand from this goldsmiths. Okay, so those who make gold ornaments, so they have demanded the a printer which can print the ornament. But the thing is like, we have to print gold, and gold is a so costly item. Okay, so if in the nozzle of that particular printer or anything that we are or the machine that we are making, if like 1 gram only if got wasted, so it will be a huge waste to the firm, right? So we need some precise and very efficient printers for that, these kind of things also. So definitely in the world research is going on for making certain printers and innovating additive manufacturing up to a next level. Okay, so yeah, so for your answer, like coming to your
Ye-
question, that ceramic and metal, yeah, definitely ceramic and metal all are
Great.
can be printed, and we can
Ye-
say it can be printed up to a certain extent. But yeah,
Great, great.
we want to do more research to get more effective and
Correct,
efficient
correct.
for printing metals and ceramics, right? Because
Sir,
nowadays
one more thing I was a bit confused was related to, now we know the rapid prototyping
hmm,
overall process,
hmm, hmm,
but so you obviously for prototyping first you will need a model, correct? 3D model, and then only you can that data conversion
uh-huh.
or production, and then that is okay.
Hmm, hmm.
But does the modeling 3D modeling is the first step or costing is the first step? That is what I was confused. So
So first step is the first step is the thinking, like or visualization of the idea. Okay,
correct.
in the first step you will just visualize or the idea will click on into your mind, so that there's a demand, and this kind of demand, or there's a problem, and this that problem can be solved using this particular technique or technology or this particular innovation. So that will come to your mind, and then from there you have to converse your that those thoughts into some concrete product. So then you will start
first of all you will start sketching, so it comes into the modeling part. Okay, so once you prepare the model, then you will go for that costing. Okay, costing in terms of optimization of the materials that you will use, and the process that you will use, right? So first is the, like, for your question, the what I say or what I feel is the uh, this modeling is the first step, or the step before the costing. Okay.
Okay,
Hmm.
okay, okay.
So after modeling, after modeling, you will realize that okay, these are the particular features that we want, that you want, and that particular feature should be fulfilled by these amount of materials. Whenever you use this softwares like CAD softwares, so you will see, the firstly you have to make that particular component, particular what you can say, drawing, and then you will select the materials for that particular thing, right?
Correct, correct. And
So
even that conversion and all that, that comes like we will
uh,
have to convert into STL and all that, and then
so
it will go for additive manufacturing. So
yes,
that,
yes,
and then it will be produced. So
yes.
all that data conversion, production, etc. will come
Later.
later. First
Yeah, yeah.
is the 3D modeling, right?
Yes, yes,
Idea.
yes.
Yeah,
Yes.
yeah.
So idea to visualization of idea which is in your mind, to
Okay.
a visual thing, so that others can also see your idea, right? So this
Got
CAD and this computer aided manufacturing came in 90s, like in 90s of era. So when after computer came, and then become popularized, and then softwares came. So not 90s, you can say, in early 20, this 2000s. Okay, so when this came, it was in very, like, in today also it is very demand, but at that time it was a very popular thing, so everyone want to use this kind of tools and learn
Yes, sir.
this kind of tool. So I remember in 2010, 11, 12, these softwares were not this much easier to operate, right? They used to take codes, so we used to write code for creating a line in AutoCAD. So I have used AutoCAD. So at that time, people used to write code for that, simply to create a line or to create some structure. So with the help of a code, we used to generate 3D model. So later on, the features were converted to the user interface, and these softwares are very popularized. So CAD modeling is a very, what you can say, unique, and another level of innovation which come, and which has made the life easier, much easier for a people, for a product designer actually. So he used to imagine the things, then instead of sketching on a pen and paper kind of thing, he used to sketch in the computer, and then others can also, he can also visualize the thing, that yeah, what he had thought, is it similar to that, it will look similar to that or not, and then others can also see and then give feedback to him ki what changes that are required, right? So yeah, so this is a very interesting topics. This, like, these are very interesting thing that uh, any engineer or anyone who knows about, like, they used to fall for it. Okay, and as a newbie, you can say, who is going to get introduced to this topic, they can definitely, it is our responsibility, so that they can also love the same love the concept, and adore the concept actually, with the same feeling that what we have got, okay, after seeing the technology, or after hearing about the technology first time. So today I'll try to give you the feeling of that. Okay, how this additive manufacturing and everything is there. Okay, so uh, let me, before sharing that, I just wanted to let me play a video for you all. Again, sharing will be a problem. Just maybe today's session will be some, maybe full 2 hour session. Uh,
So today only I'm facing these glitches. Okay, so like I'll share that those content later. Okay, maybe in terms of link you can watch it. We'll start this first part of the session, and then subsequently I will discuss more about additive manufacturing and all. Okay, so yeah, the first question is on your screen, and I hope you guys will participate in answering these questions. Okay, so after completing this part, I will discuss more about additive manufacturing and 3D printing. Like whatever knowledge I have, I wanted to share it with you. Okay, so first question is on your screen. First question says many parts can be directly manufactured in rapid prototype machine. Is it true or false statement? A very simple question. Answers, please. Yes, true. Others, please answer. Yes, so it is a true statement only. Okay, no need for further discussion. We all know. Question number two is on your screen now. Question number two says, how many cameras are used in photo sculpture while shooting a product? 24. Okay. So in the course content, we have two types of things were there. So one is topography and another is photo sculpture. Okay. So in topography, for a brief idea, I just want to share. Like in a topography, we make topography to arrange the components or arrange the items in an area. Okay. So suppose if you want to build some buildings or something like that, okay, some construction work you have to do. So the what you can say, the model that we make for showcasing the upcoming project is comes in topography. Okay, and then next is photo sculpturing. So here what we do, with the help of camera, we used to create the structure of that particular component or object. So what we do, we use certain number of cameras. So answer for that is C. Okay, so yeah, certain number of cameras is 24. So we use 24 camera to capture the image of a component, a single component, from all 360-degree side at same time. Okay, and after capturing the image, we make slices of a round pipe. Okay, so suppose there's a pipe or a hollow cylindrical thing. So we strip it into 24 parts, and at each part we used to paste the photo from each camera, and then subtracting the overlapping, we'll get a what you can say, the complete view of that uh, particular object. Okay, this is what photo is all about. So these are the old technology creation. Okay. Next question, question number three is on your screen. It says, which of the following are displaying systems accessible to make 3D outlines? Which of the following are displaying systems accessible to make 3D outlines? So the options are wireframe, surface modeling, solid modeling, all of these.
Okay, all of these, yeah. So yes, all of these are is the correct answer. So to make the 3D outlines, so yeah, what is wireframe? What I was talking about, that we have did in our childhood, wireframe structure. So with the help of what you can say, this matchsticks and all, so we used to make some frames. Okay, and for our projects also, we used to create certain frames with the help of some wood, and then we used to paste this paper and all around it, so that a 3D object or 3D box should be created. Okay, so this kind of work we have did. So that is wireframe model. In wireframe model, it is a 2D kind of thing. If we draw it on the paper or on the screen we see, so it is a 2D kind of thing where lines are used. Okay, lines and vertices are used to to create that the particular design, or the particular um, model of the object. Okay, so only lines are there, and then it mimics, or it shows us the actual how the actual components, like what is the outline of the actual component. Then from wireframe, the surface ideas came, like if we wrap a paper over that those lines. Okay, or you can say, like if we move from one place to from one line to another line in the same plane, so that a plane is generated, right? So that plane is the, like, will give us a surface. So that is a surface modeling, and then it comes like when we fill the uh, all the space remaining, so we'll get the solid modeling. So solid modeling is the one of the easiest thing, that and easiest and the most visualize, like as a visualization purpose, this solid modeling is one of the mm, prominent modeling that gives us the view of the component or the object that we are designing. Question number 4 is on the screen. It says wireframe models don't contain surface and volume information. Is it true or false? Based on the discussion what we did, what do you think? The wireframe models contain surface and volume information? Yeah, oh, Shiva. A. How A? Hmm? Do wireframe model contain surface and volume information? Because in wireframe, what we are doing, we are just taking lines and vertices to represent the model, right? So it is kind of net kind of structure. So if there is net kind of structure, surface is not existing, right? And then volume, how definitely it is not there. So yeah, this is a false statement. Sorry, this is a true statement. Sorry. Siva is right, because it is a negative statement. Don't contain it, like. So moving to the next question. Yeah. Which of the following processes don't belong to rapid prototyping process? Options are exporting data validation and repair, file manipulation, none of these. Don't belong to rapid prototyping. Okay, again, there's a negative line is there. Don't. So all this belongs to rapid prototyping. Okay, so in the rapid prototyping, first of all, we used to create the model. Then we create, when after creating the model, we convert that model into a relevant file feature, that is .sql is the most commonly used thing. So from there, we used to give it to, like, export the data, then to the rapid prototyping software. So that software do some calculations and validation before starting the manufacturing process. Okay, and then if there is some error in the conversion, earlier conversion, so it repairs, and then like certain kind of file manipulation is also done at later stage before starting the actual printing operation or printing process. Okay, so answer is none of these. Okay. Next question, question number 6 on the screen. Which of the following processes users uses laser to make voxel and the sap in thermosetting? So in which process lasers are used? So stereolithography, liquid thermal polarization, beam inference solidification, none of these. Beam inference solidification. Okay. So in beam inference solidification, what we do, there are two beams at a right angle, okay, or maybe a certain angle. So they strike inside the medium, okay, and then they solidify that particular medium, okay. So at the interference, a certain intensity is created so that it can solidify the component, okay, solidify the particular medium to a component, okay. So that's the beam interference solidification. Answer for this question was liquid thermal polarization, where we are using this what you can say, uh, a thermosetting. Here it is mentioned in the question, thermosetting materials are required. So in that, this liquid thermal polarization process uses this laser, okay, to create the required object. Next question, question number 7 is on the screen. It says beam inference solidification utilizes two laser shafts mounted at right edges to each other, which emanate light at various frequency to polymerize gum in a straightforward way. Yes, we just discussed. It is a true statement only. Okay, so it is like at at a right edges, it when the interference is when the two lights strikes, and at the interference of that, certain intensity is generated to which can solidify the medium. Question number 8 on the screen. Now question number 8 says, in fused deposition modeling, the assembled material is warmed to 0.5 degrees Celsius. uh, Fill in the blanks its melting point. Options given are under, over, times, means 0.5 degrees Celsius under is its melting point, or 0.5 degrees Celsius over its melting point, or 0.5 degrees Celsius times its melting point, or none of these. Answer for this question. Question number 8 is on the screen. C. 0.5 degree times 0.5 degrees Celsius times. Okay. So FDM is the most commonly used additive manufacturing process, and FDM printers are most frequently, like highly in demand, and they are if someone who knows about additive manufacturing, they certainly have used this fused deposition modeling based printers. Okay, so in these printers, I will show you. I was sharing that video which was showing that FDM process only. So in the FDM process, like the the material is fused in a liquid or some semi-liquid form or paste form, you can say, and then deposited in a particular pattern to create the uh, component or required object. Okay, so this 0.5 times of melting point is, I think, it's not a correct answer, because we need the material to flow. Okay, so for flowing of the material, uh, it is something like maybe 0.5 degrees Celsius more than that of the melting point, so that when it flows down and comes on the, what you can say, substrate, like where the deposition is going on, so just like not more than not higher, not at a higher temperature than melting point, okay, because if it is there, so the after deposition, it may take time to cool off, and during cooling there may be some thermal stresses or something like that should induced. Okay, so to avoid all these things, the optimized what you can say value mm, uh, for warming or for the temperature of warming the fused material is 0.5 degrees, like slightly more than that of the melting point. Okay, moving to the next question, question number 9. Question number 9 says, why does the powder used in selective laser sintering is heated with a CO2 laser? So again, selective laser sintering is a selective laser sintering is a additive manufacturing process where laser lights are used to melt or fuse the particles of particular metal or particular material or powder of that material into solid component or solid object. So why it is saying like heated with CO2 laser? So options are given so that they cannot fuse together to overcome the surface tension of the particle, to fuse the powder particles, both to overcome the surface tension and to fuse them together. What is the answer for this? Okay, so there's no answer. I'm telling you that, yeah. So this is done for like overcoming the surface tension and also fuse them together. Okay, so this laser sintering is done to fuse only. So A option is already discarded. Only these two are there. So it is like it is done to overcome the surface tension or between the what is the particles and then also to fuse them together. Okay, so the powder should get fused. Last question for this session is like rapid prototyping has its application in which of the field? Engineering design, analysis and planning, tooling, or all of these? C. Okay, tooling. Shiva says all yes. So the application of rapid prototyping is in all of the mentioned application, like in engineering design, analysis and analysis and planning and tooling. So rapid prototyping is involved at every and each stages, right? So again, this week there was no question. Uh, oh, sorry. I just
So these were the questions from my side. This week again there was no question on the discussion forum, relevant question on the discussion forum. So I have not taken any. So if you have any question or any query, now you can ask. I'm here to resolve your query and answer your questions only. So I will be here for like till 5 p.m. Please let me know if you have any query or anything that you want to ask to me.
Okay, so this was all about today's session. Sorry for the technical glitches that has come today. We'll meet again next week on next Saturday with in same time from 3 p.m. to 5 p.m. I'll be here to resolve your query and we'll discuss about the course content of week 10 and okay, so that's all for today. I'm closing the closing this meeting for today. Thank you.